Okay, here comes a quick lecture version for Design 300. It's being recorded right now. For those of you who are in the class right now, get my mic turned on. So here we go. It's being recorded. Lecture 300 for everybody who's in class right now on the Discord side and on the Google Meet. So welcome everybody. Here's what we got going, today. We're doing a new section. So let me get all of my microphones turned on. There we go. I think I was off there, and I don't think I have all my screen shares turned on either. Okay, I think that stopped the blinking. There we go. Okay. So, here we go. We'll just start running with the show. So, overall, very good work on the submittals for Unit 6, 1, 2, and 3. I think I just posted, though, an announcement. There's a wide range in the ability to do formal writing, and it's very important for designers and engineers to be able to write in a kind of formal, semi-scientific, but very direct, clear, and concise manner. And RAD classes, reading across the disciplines, actually help you prepare for that. The type of reading that they'll do in RAD and the type of thing that they'll do. So, and there are a couple of the teachers that know me and can help you prepare for that. So if you feel like you had any problems, you can look at this announcement. There's a set of classes, very short term. It's half unit, 2 check-ins per week with a reading instructor. And a lot of that is like if you're reading specifications that are 60 pages long, how do you find the part that you're interested in that's only 3 paragraphs out of that? And things like that. So you can talk to me or talk to them about it if you feel like you could be well served by getting some additional work in what's called a RAD class, reading across the disciplines. So there we go. Let's now go into our new material research project, which is about structural steel in general. And you can pick one of these topics that are associated with structural steel to write your first page of your research on. Okay? Structural steel shapes and members and their classification system. So knowing when somebody says it's a C15-32, what does that mean? It means something. And it helps you understand where to go to look up the properties and how it works. So there's a whole bunch of different structural steel shapes, and there's a classification system for those. Or you may look at MIG welding or riveting and bolting as a method of attachment. Those are 2 methods of attachments. Or you might be interested in what's called finite element analysis, which is a way of analyzing the strength of your structural steel member, your structural steel frame, and see if the deflections meet code, if the stresses meet code, and just what types of joints you might be putting on there. Now, of course, you're just going to research about it, but you could try to do one. Okay, so refer to your comments from 6.1 and hi Athena, and see what those look like, and then follow those and see what you've got. So we're going to do the same thing, though. It's summary of the product and process. So it's either a summary of steel shapes and the classification systems, or a summary of MIG welding, or a summary of riveting and bolting, or a summary of finite element analysis. Where, how, and why are those used? What are the benefits? What are the drawbacks? And are there master format specs? Now, I'll tell you right off the bat, there are no master format specs for finite element analysis because it's not a construction product. It's a design process. Okay? And it's been around for a long time. It's calculus based, but you don't have to know any calculus. There's no screen going on. Sorry about that, Lena. I thought I had them all turned on. How's that? That looks better. My apologies for that. You haven't missed much yet. That's good. But there's no master format spec. There are master format specs for riveting products, welding products, and some stainless steel, structural steel shaped products. Okay, but they all have all of the other parts. And again, you want to, if you can, include some. You want to be able to include some images to help the reader understand that you know sort of what's going on too. Okay? So let's take a look at what the study material might be like. There's engineering toolbox. You can go right to the structural C channel and you see a whole bunch of stuff and you see numbers here. And they all start with a letter and then they have two numbers followed by an X or separated by an X. That all means something. And if you stare at it long enough, you'll probably figure out that the C means the shape, C channel, and that the first number happens to go with this first column here, and that the second number goes with the weight per foot, pounds per foot. So this tells you a lot about the piece of material just with the name of it, and you can look it up, and then from that you can tell the dimensions. There's these things called moment of inertia that are very, very important in understanding how it will help carry a load. And same with the elastic section modulus. Those are numbers that help it let you know about carrying the load. The moment of inertia is based on the geometry of the shape. The elastic section modulus is also based on the shape. So those are based purely on the shape. Okay, and so is the sectional area. Okay, so these are all things that have to do with the shape and not the materials. So if you, and these are for structural steel channels. And then if you want to, you could go look up some other ones. You could go down to the bottom down here and you'll see that there's steel angles and hollow squares and beams and angles and flats and plates, and I think there's wide flange beam. So there's all of these things that you can look at and start working on. And then there's even common trusses. Okay. So these are all, this is a good place to start. It's a good place to start. Okay. From there, you might go to the architect's toolbox, which has sort of the same thing, but it actually tells you about the classification system, and it gives you Um, different, there's a T obviously and a hollow square and a C channel and a standard beam and a bearing pile and a wide flange beam. Okay. Okay. So, and this tells you a little bit about them. It's kind of cool. And look, there's all sorts of other stuff, master format specs and all this. So these are great places to start your research. To start your research. Because you want a summary, if you do this, a summary of this classification system. If you work on MIG welding, here's a really nice page that just talks about the basics of MIG welding. You might compare it to TIG welding. You might want to say what MIG stands for, how it's accomplished, some of the metal preparation. So this is a good starting place. And then you can move on from here as you get more. There's the G in MIG stands for gas. So you have to select the right gas for the right tool, for the right core, for the right material, for the right heat and the right settings. There's all sorts of stuff. People think sometimes that welding is not very technical, but it's super technical. And you got to be good at reading charts and all that kind of stuff. It's also an excellent paycheck. Let's see. Allow cookies. There we go. How much the wire has to stick out. Look at all this stuff to figure out. And that's just off of one website. Okay, so that's if you want to write. These are cool. I mean, MIG welding is really, really cool. It's a great process, and it's one of the most commonly used in the building structures industry. And that's one way of putting steel together. Another one is riveting and bolting. And so sometimes you will find that riveting and bolting is called for, or it's approved or desired. And so you should know a little bit about that. So here is a very, very beginning one about riveting that you can go on and start looking more up. But this gets you sort of started so that you even know what a rivet is. And there's tons and tons of stuff on YouTube and on Google about riveting and bolting. So that's a very cool style of putting things together. And most buildings have some sort of combination of those. They each have their own benefits and drawbacks. So at different parts of a building, you might use different processes. And then the last one is to look at finite element analysis. So you're going to pick one of these for your research on page 1, 7.1. One of these will be used on page 7.1. Okay, and you can even try using Inventor. I can help you, or somebody else can, to do a frame analysis. And this tells all about it. Okay, what is a frame analysis? And it is a simulation, and how you do it and what you do. And look at step 10. Oh my God, 15. Oh my gosh, there's a lot to it. But once you've seen what a frame analysis is, you can even look it up on YouTube or ask me to do a demonstration video for you. What it does is it tells you all about the ability of your frame design. And a frame is just a bunch of structural steel hooked together, either through welding or through a different joint structure. And it tells you about how well that frame is going to work under different loads that you can put on it. So you can put side loads and down loads and up loads and vibrating loads and live loads and dead loads. And you can check all those out. And because the structure is pretty complex, it's very hard to calculate it. So we use the power of computers and what they call finite element analysis, which is based on calculus. But instead of doing calculus, they take the process of calculus and do it in the what I call guess and by golly. So they'll guess, use the results to make another guess, use those results to make another guess, and they guess in such a way, it's actually called the Newton-Raphson method. They use those guesses in such a way so that they get closer and closer and closer to a usable answer. And a usable answer is one that ensures the safety of the building. And they've developed this so much that the answers are actually very, very, very good and true and right if you have used a good model. So it's kind of a cool process, and we can show that to you if you're interested in it. I can do a video for you if that's what you want to choose. But you're going to have to do some investigation first and show me some stuff and then say, hey, I need a video on this because I can't really find a good one. So that's the topic. You're going to pick one of those topics. And as we did before, a summary, where and how it's used, benefits of use, drawbacks of use, and a master format spec. So that's going to go into your portfolio on 7.1. The next part, which we'll talk about on Thursday also, is now you're going to jump not necessarily to your product or process, but to about A36 material in general. How is that material standardized and controlled? And you can imagine that you want to make sure you get the right material. How is the welding workforce prepared and trained? And what tests are run to make sure that welds are correct and right? So that's sort of what this week is. Again, these I'll be able to check them when you do your preliminary pre-check on Sunday submittal, and then I'll be able to look at your final one in 2 weeks. Okay, so we'll go over this more on Thursday. I think what I'll do right now for... Oh, and there was one other thing I wanted to go through. And that is the alternate, for those of you doing the alternate. So I got some excellent results from the description of the simulation environment. So we have a few people that are ready to get onto the site and start working it. And so this is what you're going to do if you're working the alternate, which is in Minecraft, doing the construction project. You're going to walk the site to verify that the plans are drawn as compared to the actual site. The drawn plans compared to the actual site is just like what you would do on a regular project. You're going to check the location of landmarks, see if there's any unobserved landmarks. Just make sure that the construction project looks feasible, and then you're going to do a markup of the drawing. Then you're going to stake it, and that's measuring from the known landmarks and putting things in place. And then you're going to excavate, do a building pad. So here's the site itself. It's in the plains biome, and these are the coordinates of it. You can see the coordinates up here, and that's what it looks like. I am facing up is north, to the right is east, and I'm at about an elevation of maybe 75 meters over the ground right here. Okay. And the actual, so you have to walk that site, and then you have to take this map and mark it and prepare it. So you have to mark the boundary, which I've made very simple. Here's some coordinates. You have to excavate, mark it for excavation, and fill, and mark it for the pad, and mark where you're actually going to cut and fill. Okay? And you have to get down to certain elevations and certain, so it's a real project. And of course you have to mark up this drawing to see if I've got it somewhat right. You're going to see that I'm missing some parts that are like, that's real critical to know that there's water there. We will be using this site in Design 350 as a sanitary drain development project for trying to locate a septic tank. You cannot be more than 150 feet from clear water running surface water or even underground water with septic. So we have to figure out if there is a place that we can put septic on this site. You don't have to do that, but we'll be doing that. So those are some of the things that they're going to do in the next 2 weeks for the alternate. They'll access the site map, walk the site, stake the site, and then they're going to do the excavate, fill, and pour pad to get ready. Okay? If you want to jump over and do that, you're welcome to do that. If you would rather do that than the metals research project. Okay? You just have to let me know and I'll make sure that you can get in on that. Okay. Let's see. I think that's actually the and pardon the background noise. My son's doing some recording for his online jazz combo class at Chico State, and since he's not living at Chico State, it's all happening right below me, so that's kind of cool. All right, any questions on all that? Do you guys understand what Abdul, do you have any questions for us? Kate, Lena, do you have any questions on what's required or where you would want to go? Okay. So I'll be looking for, Abdul, do you know where to find the template to put this information in? Okay. All right. Well, then that's really the lecture for today. What I'm going to do is I'm going to go ahead and stop the recording.